Right. Next exercise is 1.3. Okay. So first one, write the following rational numbers in decimal form and also state which are terminating and non-terminating decimals. Here there are 5 sums are there. So let us cross check. In order to find the decimal form, you do just a normal division. Okay, normal division. Clear? So I will take it as 229 by 400 is there. Let us see second problem. 229 by 400. What is the decimal form of this rational number, and also state whether this is terminating or non-terminating decimal. Clearly, when the denominator is in the form of 2 to the power n into 5 to the power m, where n comma m are non-negative integers, then definitely that will be in decimal form only. For this, you try to solve normal division method only. Okay. So here 400 with respect to 229, you find it 400 will not go, so let us take a point. So you will get here point. 4 5s are 4500, right? 5 means 5 4s are 20, double zeros, so left over with the 290. Okay. Next is one more 0. 4 4 6 are 24, 4 7 are 28, 7 you will get, 7 4 are 2800. Next 100 will be the remainder. Next one more 0 here, 4 2s are 800. Okay, here 200 will be left, right? So 0.0 200 will not go, so you will get one more 0. So 4 5s are 20. Clear? So 2000. These all are minus. So the decimal form of, therefore, decimal form of 229 by 400 is 0.5725. 0.5725 is the decimal form of 229 by 400. And what is that? Which are terminating and non-terminating decimal. If you get remainder 0, it will be terminating decimal. If you don't get remainder 0, if it continues like that, then you can conclude that it is a non-terminating repeating decimal. Clear? So for this particular problem, this is terminating decimal and the decimal form is 0.5725. Right? That is about first bit. The remaining sums you can solve in the same method, and they are with only small fractions, 3 by 8, 4 1 by 5, 2 by 11, 8 by 125. They are very small. You can do easily. Okay. Now after this, next second bit. What is second bit is? Second bit is nothing but without actual performing the division. We need to find out the rational numbers will have terminating decimals or non-terminating decimal form. See, without doing you can say easily, but here second problem is 11 by 12 is there. In this second bit, second problem, 11 by 12 is there. Clearly one, we have to know that if the denominator, the prime factorization of the denominator of a fraction is in the form of 2 to the power n into 5 to the power m, if any denominator can be expressed as in this form where n comma m are non-negative integers, then definitely that fraction will be in terminating decimal form. We have terminating decimal form. If that is not, if the denominator is not in this form, so in that case we can say that it is non-terminating repeating decimal. If it contains only 2 to the power n also, we can say that it is a terminating decimal. Why? Because m, suppose if it is 2 cube is there, suppose 8 is there, if it is 8, it can be written as only 2 cube. But 5 power m can be written as 5 power 0, no? Why? Because m and n are non-negative integers. It may be 0. So 2 cube is nothing but 2 cube into 5 power 0, or else if it is 5 square, 2 is not present, then also you can say that is 2 power 0 into 5 square. Okay, if the denominator is only in the form of 2 to the power m, or only in the form of 2 power n, or in the form of 2 power m into 2 power n into 5 power m, in all these three cases, this particular fraction will have terminating decimal, otherwise it will have non-terminating repeating decimal. Let us cross check here. Only these two should present, upon no other prime factor should exist for that. Now clearly, if you do the 12 prime factorization, what will you get? 2 6s are 2 3s are. So 12, the prime factorization of 12 is 2 square into 3 to the power 1. Clearly this is not in the form of, clearly prime factorization of 12 is not in the form of 2 to the power m into, or 2 to the power m into 5 to the power n, where m comma n are non-negative integers. M comma n are non-negative integers. Clear? So what we can conclude, 11 by 12 is a non-terminating repeating decimal. Non-terminating repeating decimal. Right? Simple. We have to do the prime factorization of the denominator, then you can conclude it. Some other problem is there. Let us cross check here. Sixth one you check out. Sixth one. The sixth problem is 23 by 2 cube into 5 square. Here you need not to do any factorization. Why? Because the problem itself is in prime factorization form. So clearly it is in the form of 2 to the power m into 5 to the power n. No? So it will have terminating decimal. Clear? It will have terminating decimal form. So clearly it is in the form of, you can write like this. Clearly denominator, prime factorization of q. Denominator is in the form of 2 to the power m into 5 to the power n. Isn't it? Are you following? So therefore 23 by 2 cube into 5 square is a terminating decimal. Is a terminating decimal. Done? Right. In this one more problem is a, let us cross check here. 77 by 210, last problem. 77 by 210. Here directly don't do the prime factorization. Here both numerator and denominator should have co-primes. These two will not have any common factors. Here also this is a prime number, this is a composite number, will not have any common factors other than 1. So but here they have a common factor here. 7 table, 7 11s are, 7 30s are. These are not co-primes. You have to make them as co-prime, then you have to do the prime factorization of q. Clear? So suppose if any problem come across in this form, if you directly do the 210 prime factorization, your answer will get wrong. Clear? So now 30 prime factorization is what? 2 15s are, 3 5s are, 5 3s are. So clearly this is in the form of prime factorization of 30. 30 can be written as 2 into 3 into 5. 2 into 3 into 5. It should be in the form of 2 to the power n into 5 to the power m, but not 3. 3 is extra. So it is non-terminating repeating decimal. Therefore 77 by 10 or 11 by 30 is non-terminating repeating decimal. Done? I hope you understood this point, right? In the second bit, in the third bit, what they have given, same problem, but they ask you to find the decimal form also, without doing actual division. Without performing the division, you need to find out the decimal form in the third bit. Let us cross check how to do it. Okay. Now, third bit is, without performing actual division, you need to find out the decimal form. Here 13 by 25 is there, first one. Third bit, first one, 13 by 25 is there. In this case, what we need to do? How to find? Same prime factorization you have to do. 13 prime factorization, 13 by 25 is 5 square, right? So just in this case, what you need to do is simple. You need to multiply and divide with some other factor. What is that factor? Means you need to make the denominator as multiples of 10. You need to make the denominator as multiples of 10. So in order to make it as 10, what is shortage here? 5 is shortage, right? I'm sorry, 2 is shortage. So you multiply and divide with the 2. But how much 2? 2 should be raised to the power what? 2 should be raised to the power this power. Whatever the 5 contains, that power you have to raise it. So 2 square by 2 square you multiply and divide. So that the answer will not be changed. So 13 into 4 by this 5 square into 2 square, can I write as 5 into 2 whole square? Yes. Yes, this can be written as, what is this? AB whole square can be written as A square into B square. This is exponent formula. Now 13 4 is 52. This is 10 square. 5 square 52 by 10 square means 100. So in the numerator you will get, after 2 digits you will get decimal point. Why? Because in the denominator you have multiples of 10, that is 2 zeros are there. So in the denominator, in the numerator, after 2 digits you need to place a decimal. Clear? This is the decimal point. I have not done any division. Just I multiplied and divided with the shortage of term which required to form denominator in the multiples of 10. Right? In the same way, some other number, 7 to 180 by 3 square, 5 square is there. 7 to 180 by 3 square, 5 square, that is fourth one. 7 to 180 by 3 square into 5 square. Right? Now tell me, in order to find the decimal form without actual performing, there should be co-primes. Already I have discussed in the previous problem, right? But here these are not co-primes. 3 square exists and this is a multiple of 9. Okay, so first you simplify this. 7 to 180 by 9 into 5 square. 9 8 is 72. This is 9 2 is 18. 0 9 2 is 18. Why? Because 2 digits at a time you have taken, that's why I have kept the 0 there. Okay, so 802 by 5 square. Sorry, 5 square. Now that 802 by 5 square, what is the shortage here? 2 square. Again same. With the 2 square you multiply and divide it. 802 into 4 divided by 5 into 2 whole square, that is equal to 4 2s are 8, 4 0 0, 4 8s are 32 divided by 10 square, that is 100. So answer is 32.08. Clear? Right. Suppose if any other problem is there which is in the form of 23 by 2 cube into 5 square. 23 by 2 cube into 5 square. In this case, what will you do? Here 2 is present, 5 is also present, but they are not having even powers. You have to make them even powers, then only it becomes a multiples of 10 denominator. So what is the shortage here? Here power 3 is there, here power 2 is there. So if you multiply and divide with 5, so this become 5 power 3, this also becomes 2 power 3. So both will be multiples of 10 it becomes. So just you try to multiply and divide with the 5 in this case. 5 by 5. Clear? So 23 into 5, 5 is a 15, 5 to the 10, 11, 115 divided by 2 cube into 5 cube, which is equal to 115 by, I think, 1000. So the decimal form of this is 0.115. So in the numerator, after 3 digits you need to put a decimal. Clear? So this is the way to find the decimal form without performing the division. Clear? So second bit and third bit both are same, but in the second bit we have to say whether it is terminating or non-terminating decimal. But in this case, in the third bit, you have to find out the decimal form without doing without performing the actual division, right? So last bit, but not least, so they asked you to find the fraction. So they have given the decimal form, you need to find out the fraction. So that is also small, there is a shortcut for that also. Let us see here. Okay. Now, the sum in the fourth bit is, what they have given is 43.123. This can be easily, the decimal point is there, that can be done easily without having any decimals. 0.1201201. These also can be done. 0.1201201. Right? This we have to find out in the P by Q form, and what are the prime factors of Q they are asking. So very simple, no? What is this? You remove the, without having the decimal point, you try to write 1201201 divided by, instead of this decimal point 1, now count the number of digits. 1, 2, 3, 4, 5, 6, 7. Right? So 7 zeros you will get. Right? Now, you have, what you need to do, they are asking you to find the prime factorization of the denominator. What are the factors of Q they are asking? What are the prime factors of Q they are asking? Just 1201 by 170, right? 1201. Now prime factorization of Q they are asking, right? So 120 by, this is 10 to the power 7 is there, right? 1, 2, 3, 4, 5, 6, 7. So it can be written as 120 by 2 into 5 whole to the power 7. So 120 by 2 to the power 7 into 5 to the power 7 is the prime factorization of Q. Prime factors of Q are, Q means denominator. This is P by Q form. What is this? P by Q form. Clear? So prime factors of Q are, prime factorization of Q is 2 to the power 7. Prime factors. Right? Prime factorization of Q. Q is nothing but what? 10 power 7 is equal to 2 to the power 7 into 5 to the power 7. Right? Now in this last there are two bits, 43.12 bar and 0.63 bar. It's very simple. Third problem, 43.12 bar. I have given this type of problems in charts also. Just you go through the charts, you will come to know how to this. Shortcut method I have already discussed here. So once again I write. So first, in order to find the P by Q form, just write the total number without having any decimals minus non-repeating digits 43 divided by, write as many 9s as there are repeating digits in the numerator, okay, and followed by zeros as many non-repeating digits in the decimal part. There are no repeating digits in the decimal, non-repeating digits in the decimal part. So that's all. Now 43 minus 43, 12 minus 3, 9, and this is 0, 10 minus 4, 6, right? 4, 2, 6, 9. Am I right? Divided by 19, 9. And this is 6 plus 6, 12, 12 plus 9, 21. I think it goes in simplified form, you have to do it. Right? So 3 3s are 9. 3 table it goes. 11 table, let's check. 3 3s are 3 3s are. Or else 9 table also it goes. 9 table, no, 3 table 1. 3 1s are, 3 4s are, 3 2s are, 3 3s are. 1 4 2 3. So 5 plus 5 10. It won't go in 3 table. So that's all. 1 4 2 3 by 33 is the P by Q form of 43.124 bar. Now prime factorization of Q is simple. Prime factorization of Q. Q is nothing but 33. Is nothing but 11 into 3 or 3 into 11. Done. One more is 0.63 bar is it? That's simple. 63 minus 0 by 99. 63 by 99 is the answer, or else 3 2 the 3 1 the 21 by 33. Clear? Again it goes in 3 table, again 6 3 into 3 9 table it goes, I think so. 63 9 7 the 9 99 will get 9 7 the 9 7 by 11 is the required answer for the last problem. Okay, I hope this exercise is also clear to everybody, right? Please, if you feel that it is very useful for you, please like and share and subscribe my channel. Thank you for watching.